Welcome back. Before we talk about MCP, we need to understand tool calling, also called function calling. When you sign up for an API key with a model provider, Anthropic, OpenAI, Google, you get exactly one thing: a dumb model. Text in, text out. It knows only what it learned during training. No internet access, no live data, no ability to take actions in the real world. Tool calling changes that. Instead of answering directly, the model emits a structured call. Your application executes it against a real API and returns the result. The model then uses that result to write its final response. Let's look at this with a hands-on example. Welcome back. Let's navigate to the UV Astral installation guide. Here, you will see installation for Mac OS, Linux, and Windows. In our case, we will go ahead with the Windows specific installation command. Let's copy this and let's move on to the fresh directory that we created. I'm going to paste this command, hit enter, and this will download UV specific files. The installation is complete. At this point, the most natural thing to do is close and reopen this window. We are now going to check the UV version. UV is now installed and recognized. Now that UV is working, the next thing I want to check is which version of Python is available by default. I'll also list the different Python versions available on this machine. In my case, I can see Python 3.13, which is the default. The official MCP Python setup requires Python 3.10 or higher, and my machine already has Python 3.13 and it's active. I'm going to use that directly for this tutorial instead of installing another Python version. If you come across any blockers, I'll be happy to tackle them in the comments. I'll be adding a minimum setup guide. You will find the info in the description. Now, I'm creating the virtual environment for this project. This time, I'm telling UV exactly which interpreter to use. So the environment matches my installed Python 3.30. Now, I'm activating the virtual environment. So everything I install stays isolated to this project. And now I'm verifying the active environment if it's already using Python 3.13 and that the interpreter part points to the .venv folder. With the environment active, I'm installing the MCP Python SDK with CLI extras along with IPyKernel, Pillow, and Anthropic for the rest of this tutorial. Finally, I'm importing MCP and printing its install path just to confirm everything installed correctly. This proves everything works as expected. And let's proceed on to the next step. Now that the environment is ready, I'm going to create a new notebook to demonstrate how function calling actually works. Function calling is how an LLM moves from just generating text to actually taking action. Instead of answering everything in natural language, the model can decide to call a function with structured inputs, like querying data, running code, or hitting an API. First, I'm importing Anthropic, our AI Overlords official library. Then I'm importing getPass, which basically prompts for secret without echoing them on screen. Then I'll be importing OS, a widely used utility. Instead of hard coding the API key, I'm prompting for it and storing it in an environment variable. Then I'll be initiating a client which automatically reads the API key from the environment. And here I've specified the cheapest Claude model, trying to do a lot with a little. Now let's select a kernel that works. Let's run this. It's prompting for a Claude API key. I've provided that. It runs safely. Right now, I'm just calling the model directly. No tools, no function calling, nothing fancy. I'm just going to ask a very real question. What's the weather in Tokyo? Now here's the part. The model doesn't actually have access to live data or the internet. So instead of calling an API or fetching real weather, it's going to do its best based on general knowledge. Notice how it's giving a reasonable answer. It has stayed honest and it's asking us to check the weather app. Without tools, the model can only generate text. It can't actually fetch real world data. So, in the next step, I'll give model a tool and instead of guessing, it can actually decide to call a function to get real data. Now, I'm going to give the model a tool. This is the key shift in function calling. Instead of only generating text, the model can decide that it needs outside help and request a function. First, I define a very simple function, getWeather. In this example, it doesn't call an actual weather API. It just returns a hard-coded response. Next, I describe that tool to the model. So in this tool definition, I gave it a name, description. Here, the schema says the tool expects one field, city. That field must be a string. Next, I'm sending the same question again. What's the weather in Tokyo? But this time, I also pass the tool definition along with the request. This gives the model the option to use the tool instead of just answering from text alone. Let's inspect what's R1. So this R1 variable is the model's first response. But this is not a final answer yet. It's the model deciding what to do next. First, I'll check why this model stopped. If you look at this, it says tool use. That means the model is not done. It's asking me to run a tool. Now, let's look at R1.content of 0. If you look at the actual content, this is the important part. This is where the model tells me which tool it wants to call and what input to use. In this case, it chose getWeather and passed in the right arguments. Here, I'm just pulling out the tool request from the response. Here, I'm looking through the content and grabbing the block where the model asked to use a tool. Now, I take the input from the model and pass it into my Python function. So this becomes getWeather city equal to Tokyo. And my code runs it, not the model. Finally, I print everything so it's easy to follow. Which tool was called, what input was passed, and what result came back. Before moving forward, I'll also print the tool ID. The ID is important because it lets the model match the tool result with the exact tool call it made. So far, the model asked to use a tool and the code ran that tool. Now I need to send the result back to the model so it can finish the answer. I start by repeating the original question. In the second message, I include the model's previous response, which contains the tool call. This keeps the conversation consistent. And in the third message, and this is the key part, here I send the tool result back to the model. I include the result, the tool ID. The ID connects this result to the exact tool call the model made earlier. The model does not remember the tool result automatically. We have to send it back explicitly. Next, we have to extract the final text response from the model. This time, the answer is based on the tool result, not a guess. So the key takeaway, the full loop is the model requests a tool, the code runs it, and then I send the result back to the model so that the model can complete the answer. One question, one tool call, one result, stitched together by hand. So you can see exactly what's happening at each step. In a real agent, this loop runs automatically. The model calls tools, gets results and keeps going until it can answer. If you made it this far, subscribe. There's a lot more coming. Thank you.